Yeah, I'm sorry, everyone. Let's start off. Yep. So everyone had a good vacation and you have gone through the notes. So last thing that we are doing was potential energy of center of mass and kinetic energy of center of mass and all this stuff. Right. Comes on everyone. Let's go ahead. Okay, we did this thing also. So let's say we have a particle of mass m projected with speed u at an angle theta. As it flies at the highest point, it explodes into two pieces. One piece m by 2 starts flying up with velocity u. And the second particle m by 2, we don't know how it flies, but it goes and falls somewhere here. The particle is projected with speed u, let's say 20 meters per second. At an angle theta, which is 60 degrees. So as this is flying at the highest point, some reason it exploded. Two equal pieces. The one piece flies vertically with the u, which is 20 meters per second. So find the position where the second particle lands. You can take the initial point as origin. So find the x coordinate of the second particle when it lands. Hope the question is clear. How do you do this? There is actually an easier version of this question. I'll show you that later. Others, do keep your cams on. Root 3. Okay, let's see. How do we do this? So listen. This particle is flying at the highest point, m. So you have a velocity u cos theta. U is 20, cos 60, so 10 meters per second. Now, at the highest point, right, just before collision and just after collision, technically speaking, there is a gravity here. Getting it? But the explosion is, happens such as so fast, the time interval is very small. You can neglect the gravity force. So basically, we can neglect gravity, or we can neglect mg during explosion since the time interval is very small. Therefore, we can conserve momentum just before and just after explosion. You're getting it? When can we conserve linear momentum? When net force is zero, isn't it? But technically speaking, when the particle is flying, there is a gravity mg. So theoretically speaking, you can't conserve. But since the explosion happens very fast and the time interval is very small, we can neglect the effect. So this is one thing keep in mind. If you have gravity, you can conserve linear momentum just before and just after if the time interval is small. We can conserve linear momentum just before and just after explosion. There now we have gone from centromos to we are slowly entering, momentum conservation. So this is the scenario before explosion. After explosion, what happened? Now you made this into two particles. So one guy, mass is m by 2, and this is flying up with 20 meters per second. The other guy ka velocity v bar, we have no idea how much is that. So we can conserve momentum. So initial momentum will be m into 10 meters per second I cap. This is equal to m by 2 into 20 j cap because it's going up, and this will be m by 2 into v bar. M cancels everywhere, send 2 that side, this will be 20 I cap minus 20 j cap is equal to v bar. Clear with this? Means after explosion, that second particle is flying with 20 I cap and 20 j cap. And what point is this? This is your h max. And what is the maximum height? U square sine square theta by 2g. Which comes out to be u square is 400 and sine 60, that will be 3 by 4 by 20. 4 is 100, 5, 15 meters. Any doubts still here, people? Go 30, 33. Yeah, right, Srihari. So you're done. Basically, collision explosion is over. Now the question has simply become as if there is a building of height 15 meters and you have thrown a particle with a speed of 20 horizontally. This is your ux. And you have thrown 20 vertically. This is your uy. This becomes your kinematics, projectile motion. This is the range. So how to find the time of flight? Sy is equal to ui t plus half ay t square. So Sy will be minus 15, Uy will be minus 20. Remember, velocity is downward, gravity is also downward, minus half 10 t square. That will be 5, so this will be minus 3. Minus n goes off 3, 40 plus t square. So we have t square 40 minus 3 is equal to 0. This will be minus 4 plus minus root over b square 16 plus 12 by 2. That will be minus 2 plus that would be 28 to root 7. Yeah, that's your time of flight. Then what is this distance here? The range here will be horizontal velocity ux into time of flight, which is 20 into root 7 minus 2. But the question is from the initial position, isn't it? So this was your origin. This was half of the range, which is half square, half into u square sine 2 theta by g. That is half into 400. Sine 2 theta is root 3 by 2. Sine 120 by 10. That would be 10 root 3. Therefore, the distance will be 10 root 3 plus 20 into root 7 minus 2. Did I mess up any calculations? Yeah, right, Utsa. Are you clear what we did? So again, the problem has two parts. Just before explosion and just after explosion, the linear momentum is conserved. So initially your momentum is all I cap, but one particle is going up, so that is J cap. The other particle I don't know, let it be V bar. The conserving momentum, I got the velocity. Once I got the velocity, the problem has become simply a kinematics problem where you're throwing from a building of height 15 meters and speed 20 horizontal and 20 vertical. I got the time of flight and range is horizontal velocity into time of flight, but this will be the distance after explosion. Before the explosion, the distance is r by 2, so this is half of the range. That is 10 root 3, so you need to add both of them. Clear with this? Arya? Samyak? Got your mistake? क्या किया? Time of flight messed up क्या? You guys took root 2 h by g.
यस अच्छा कि सेंटर ऑफ मास प्रोजेक्टाइल फॉलो करेगा तो उसके लिए
हाँ वो that is the reason I gave you this. वो नहीं था. That is and this is different. All clear with this? Now let me ask you the other question actually, which you guys are saying. Any doubts on this? All got this thing? Little lengthy, but I hope you got the process. Now let me ask you the easier version of this question. Anyone not clear with anything here? Anything you got confused here? Please ask. Great. So the easier version of the question was this. Particle is projected with u and theta. At the highest point, it explodes into two pieces. And then after explosion, one piece m by 2 will retrace the path. It goes back the same way. And the other piece m by 2 flies ahead. So basically one piece m by 2 will retrace and come back to the same position. The another piece m by 2 will fly away. Then the question is find the position where the second particle lands. A particle is projected with u and theta. At h max, it explodes into two equal pieces. One piece retraces the path. It comes back to the point of projection. And comes back to the origin. Find the position where the second piece lands. Now you can do the thing which I showed you right now. There is actually a faster way to do this. But you do however you want, it doesn't matter. I'll show you both the ways. And then we will see why the method works here and doesn't work in the previous thing.
do we have to assume the same values of u and theta as last question
No, u and theta only. मतलब वो give me answer in terms of r ना. R का terms में आंसर दे देना. R is u square sine 2 theta by g. Give me answer in terms of R. Here you'll get a good one. This you can solve in like 15-20 seconds if you actually know what is happening. The previous one will not be able to figure. Right, Srihari? Right, Samyak? Think. Others try. I'll give you a minute or something. नहीं यार, you have to tell me from the initial position. Not sure you found it from where. Let's see. Again, from the point of projection पूछा था. Right, Anvita. See, let's try to do it the previous way, okay? Little lengthy, but you need to understand. So at the highest point, this thing exploded into two pieces. So this guy had a velocity u cos theta. Great. So this is before explosion. After explosion, you said one particle retraced the path. So if you are going back the same way, that means your speed also must have been u cos theta, isn't it? Since it is retracing the path, it must have gone back with the same u cos theta. Since it retraces, so velocity must be u cos theta backward. Because time of flight will be same, na? The height is same, so both will have same time of flight. And if you want same range, so the velocity must be same. Speed must be same. Speed must be same. The other particle, I don't know how it is going. Let it be v bar. So conservation of momentum. Initial momentum is equal to final momentum before and just after explosion. Initial momentum mu cos theta I cap. This is m by 2 minus u cos theta I cap. And that will be m by 2 v bar. So you get v bar will be 3u cos theta. Means after explosion, this guy will gain a speed of 3u cos theta. Now tell me one thing. With a speed of u cos theta, you're traveling r by 2. With a speed of 3u cos theta, you will travel 3r by 2. Agreed? And the reason for this thing, because here, time of flight for all of them is root 2h by g for all of them, since vy is 0. So your answer is 2r. Is that clear, everyone? So this particle will land at 2r comma 0. So one particle will come back to origin, the other particle will land at 2r comma 0. This is how you do the problem with momentum and kinematics. The same way we did the previous problem, but this is a little easy. Is this method clear, everyone? Right, Utsa. Got this? Now there's an alternate and a faster way. And this is important. You should know because people mix up both the things. Now, in this case, it is a very special case, okay? We observe after explosion, all the particles land on the ground at the same time. That is the most important thing. Okay, so therefore, the only force acting is gravity. So it is the same force of gravity before and after explosion. Now we can make an argument like this. Since explosion is internal force, it does not affect the center of mass. Explosion is an internal thing. So explosion is due to internal forces. If you remember, we made a statement last time. Here. Internal forces do not affect the center of mass. Means it will continue with its whatever it is doing as before. So since explosion is internal forces, the center of mass is unaffected. So the center of mass will behave as if it is still flying in a parabolic path. That is, COM will continue in its parabolic path. Means when the particles land on the ground, so this is what you can do. So you threw the particle with u and theta. So this was flying, this was the path. At this point, it exploded. But the center of mass does not care. The center of mass will continue in the same parabolic path. And the center of mass will land at r comma 0. But we know after explosion, one particle retraced the path. So here we have one particle m by 2, which is at 0 comma 0. The second particle will go and land somewhere here, which will be x comma 0. That means the center of mass of this particle and this particle, shouldn't it be this center of mass? Are you getting the logic there, reasoning? Because after explosion, center of mass will be at r comma 0. So this particle ka center of mass and this particle ka center of mass must be r comma 0. The center of mass of the two pieces when they land on the ground must be center of mass of the system. Therefore, x center of mass will be m by 2 into x plus 0 by total mass m must be equal to r. We get x is equal to 2r. मतलब इतना करने का जरूरत नहीं है. m by 2 equal ना, so midpoint must be the center of mass, isn't it? So that will be 2r. You can directly say that. Are you clear with this? So this would be faster, isn't it? Without doing all the calculation, get the answer. Got the method? We get the same answer. Now my question is, why can't I use this alternate method in this case? What is the problem here? If you try to use that alternate method here, you'll get a wrong answer. It doesn't work. Can someone tell me why it doesn't work? So this method is actually superior. This momentum conservation and solving, this is a superior method, but it becomes lengthy. If it is a mains level question like this will save you time, but this does not work there. Can someone tell me why it doesn't work? Think I'll give you a minute. Why can't I use the center of mass concept in this one? So the reason say. So when you're trying to use this, always ask yourself, this is important. So in that first part, when we did that explosion problem, so we got two pieces, one is flying up and one is going something like this. Now see what happens when they're flying. Look at this motion here. This guy is going up and landing here, right? And whereas this guy is going and landing somewhat like this, who will reach the ground first? Let's call this thing particle 1 and let's call this thing particle 2. Who will reach the ground first? Particle 2, right? So that means 2 will go and hit the ground. So once it hits the ground, what will happen? You will get a normal reaction, na? You're getting the point what is happening? Now, normal reaction is an external force acting on the system. So centromass will get affected. So now you cannot say the same statement that the centromass will continue the same path. Are you getting it? The moment particle 2 hits the ground, you having a new external force. So the centromass will follow the parabolic path as long as the two particles are in the air. Because when you are in the air, the only force is gravity. If even one particle, if one particle touches, it hits the ground, it stops. If one particle hits the ground, we get a normal reaction from the ground, which is an external force. And this is going to affect the center of mass motion. We get normal reaction, which is an external force. Center of mass will not follow the previous path. It will start going in some new path. Therefore, we can't say center of mass of the system will land at r comma 0. Clear with this? Is this making sense? So why can you use here? You can use here because luckily when it exploded horizontally, both of them will reach the ground at the same time, isn't it? So when they reach the ground at the same time, the centromass also reach the ground at the same time. So this is the clue. If there is no vertical component, you can use center of mass. If there is a vertical component, don't use center of mass. Simple. I hope the method is clear. When to use and when not to use. So don't blindly always use this. You will get trapped. So this is actually an easy version. When you fly horizontally, there is no issue. But if you have a vertical component like this, you will be gone. So I can even make a question like this. Na? There will be three particles, m by 3. One is going up, one is going horizontally. Where will the third particle land? So you can play around like this. All clear with this thing? All got this? Any doubts on this? It's a good question. So especially that explosion with a vertical component is a good one. Let's see one more. These are good ones. We have a plank, smooth floor. We have a man here of mass m. Plank ka mass is capital M. Length of the plank is L. This surface is rough, or else the man cannot walk. But the floor is smooth. Now, when the man starts walking on the plank, now when he walks on the plank, how will the forces be? When a person is walking, what is the direction of friction, everyone? If you're walking forward, what is the direction of friction? Forward, right? Means at the same time, friction lag backward also. Means the moment you start walking forward, the plank will start going backward to compensate. So find the distance moved by the plank when the man walks to the other end. This is a standard one. Is this clear? So once you start walking on the plank, if the ground is smooth, the plank will start going back and you'll start going front. So in this process, how much will the plank move when you go from one end to another end? That means it doesn't depend on the mass of the man and the plank. You take an elephant and keep it on the plank, it will move the same distance as an ant. I hope the question is clear, everyone. How do you approach this? Right, Samir. Right, Arya. Listen, first thing, few things here. When the man is walking on the plank, my system is the man plus plank. Are there any forces on the system? So your system is man plus plank. So whatever friction is between them is internal because ground is smooth. Since F external is 0, acceleration of center of mass is 0. Therefore, velocity of center of mass is constant. In this problem here, velocity of center of mass is 0 because at rest. Therefore, if velocity of center of mass is at rest, that means center of mass of the man and the plank should not move. So man can walk, plank can go, but the center of mass of both of them will not move. So it doesn't matter. That means let the man, dance there, jump or do anything, center of mass of the system will remain same. That means delta x center of mass is 0. So listen, how to handle these kind of questions? I'll give you a general method. So yeah, I think most of you got it, but listen carefully. Look at the general process. So this is a plank. So let's consider this your initial position. So man is standing here. This is mass m, this is small m. So the center of mass of the system will be somewhere here. We don't know where exactly, it will be somewhere here. Now when the man starts walking on the plank will come back a little. This is what will happen. And the man has come to the edge. So in this process, if you see the center of mass tool should be here only. It doesn't move. Now my question, can you tell me how much did the man let the plank go x backward? Okay. How much did the man actually walk? Did the man actually walk distance L? He is walking L minus x na. Are you getting it? Even though we are saying man is walking on the plank is coming back and the man is walking forward. So these are the steps. Step 1. You always have to draw the picture. Draw the picture. Let the plank go backward by x. It doesn't matter. You can take forward also by x. Science will take care of it. Step 2. Calculate the displacements in the ground frame. Step 3. Use this formula. Delta R center of mass will be m1 delta r1 plus m2 delta r2 by m1 plus m2. Remember this formula? m1 r1 plus m2 r2. If you put delta, it will become a change. Now in our question, delta x center of mass of the man is small m. How much did the man move here? Let's write down that also. So delta x of man This man has gone L minus X I cap. How much did the plank go? The plank has gone X backward, which is minus X I cap. How much did the center of mass move? 0. Why? There is no external force on the system. So therefore, delta X center of mass is mass of the man into displacement of the man, L minus X. Delta X of the plank is capital M, displacement is minus X, by M plus M is equal to 0. From here we get X is equal to ML by M plus M. Are you clear with this? Check the process how I did this. Now, the method is important, how I did this, systematically. All got what we did. Let the plank go by X. The plank went X backward, minus X I cap. The man went L minus X forward. Center of mass of the system did not move. Why? Because the whole system was at rest initially. So delta X center of mass is M1 delta R1 plus M2 delta R2 by M1 plus M2. Put it there and you get the displacement. Sure with this? Any doubts on the process? The process is important. Let's see one more. I think you'll get a better clarity. Now you guys try this. Same question, but this time we have a plank. M, we have two people on the plank now. Let's call him A, which is mass M. And we have another guy, B, whose mass is 2M. Smooth floor. The distance is L. Now what happened? A and B walk towards each other and exchange places. Means B will go to A ka place and A will come to B ka place. So they're exchanging places. Both are walking towards each other. So the method I taught you here now is a very generalized form. I can put even 20 objects and this will still work. For 2 objects, it looks pretty silly and easy, but if you have more objects, you will realize. Walk towards each other and exchange positions. Find the distance moved by the plank. Let's get this. How do you approach this? Let's see. Right over here. नहीं आ रहा नहीं सम्यक नहीं रे उत्सा. Let's see video कैसा घुसेगा. Always first draw the picture. Let the plank go X backward. It doesn't matter. It can go forward also. I will take backward because we started like that. I'll do one thing. Let me just. So let the plank has come somewhere here. Okay. Now A must have gone to the other side. So this is the position of A. And B must have come this side. So this is the position of B. So let the plank go X backward. Okay. And how much did A travel? A travel L minus X. How much did B travel? B used to be here. B walked distance L and he walked X extra. So delta X of A is L minus X I cap. Delta X of B, this person walked L plus X backward. So minus L plus X I cap. Delta X of the plank, I assumed it backward, so minus X I cap. Please check these three distances first. Does everyone agree that B has walked L plus X? Clear with this? And I gave all the masses capital M only. So you're done basically. So delta X center of mass will be mass of A, which is M, delta X of A, mass of B, 2M into delta X of B, mass of the plank M into delta XP, by total mass 4M must be 0. This will be L minus X minus of 2M into L plus X plus M into minus X is equal to 0. M goes off. L minus X minus 12 minus 2X minus X is equal to 0. We get X is equal to minus L by 4. What does the minus sign indicate? Minus sign indicates you took the opposite direction. I thought it is going backward, but it is actually going forward. And it kind of makes sense. 2M is heavy now. Because the 2M is going to the left, plank will go to the right side because 2M is a heavier guy. Please see where you guys messed up the calculations. Negative indicates the motion is opposite of our assumption. So it's even if you take it wrong, the signs will take care of it. So the answer is L by 4 towards right. Clear with this? Any doubts on this? Let's see one more like this. I can make this even better. Let's say we have a square platform. This is the top view. We have two people here. A, whose mass is M, this guy is walking in this direction. So let's call this point as 1. Let's call this point as P, Q, R, and S. And we have another guy here. B, whose mass is 2M. This guy is walking along this line. And A is walking along this line. So the side view now will look like this. So this is the square platform. A is standing here, he is walking this way. B is standing here and is walking this way. This was P, this was Q, this was R, and this was S. This will be the side view. A walks from P to Q. B walks from P to S. Find the displacement of the platform. in the previous problem, if you see, they're walking only in one direction. Here they're walking in two-dimensional basically. So the platform will go up also, will go left also. It will go in some other direction. Platform ka mass is also m. Huh? So mass of the platform is m. A ka mass is m, and B ka mass is 2m. So the same previous question, I just made it two-dimensional now. Are you able to visualize the picture? So when A walks, platform will go left side. When B walks, platform will go upside. So the platform is actually going diagonally when both are walking. What is the displacement of the plank when A goes from P to Q and B goes from P to S? So there, this is how you can keep twisting the question. We started with one man, one plank in one direction, and you can go ahead. Same story. Let the plank go. Instead of saying let the plank go X, now we will say let it go X backward and Y upward. Nah, take both of them. I will by 6. God, it's a displacement. You get a vector form. Think, how will you do this? If you're getting confused to see the whole thing, then do one thing. Let one person walk at a time. First, let only A walk, then let only B walk. So this is how I would do. First, I'll assume only A is walking. That means when A is walking from P to Q, this is mass M. So basically, I'm including B with the plank only. So B and the plank are together, that is mass 3m. So when this guy walks forward, the plank will come back by X. And this result I already know, which is ml by m plus m. So that will be m into L by m plus 3m. Means you'll go L by 4 backward because P is walking. Then I will take the plank like this. Now I will say B is walking, mass 2m. And this time let person A sit inside the plank. So he's not moving, he's stuck to the plank. So you can treat this whole thing as mass 2m. So when this guy is walking forward, the plank will go backward. So picture will become like this. You just have to turn your head by 90 degrees. So this guy will come here and this thing will go by some distance y. Again, what is the formula? Small m L by m plus m. So this is small m is 2m, L by 2m plus 2m, L by 2. Are you getting how I did this? That means when A walks, the plank will go L by 4 backward. When B walks, the plank will go L by 2 upward. So therefore, the displacement will be minus L by 4 I cap plus L by 2 j cap. Are you clear what we did? See, let's say only A is walking, B is stuck. Then this whole plank will behave as if it has a mass of 3m, right? Do you guys agree with that? If only A is walking and B is stuck to the plank, that means B and the plank will move together and A is walking. Second case, A is stuck at point Q and only B is walking. Does that make sense? Whether both of them move at the same time or whether they move one at a time, the final answer should not change. Is that making sense, everyone? If both of them walk at the same time or they walk one at a time, the final answer should remain same. Because when they're walking, there are no external forces. The center of mass will not get affected whether both will walk or only one person walks. So first, let only A walk. So let only A walk. Right? And B is fixed to the plank. So the question becomes, this is similar to right, a plank of mass 3m then. This has become your first problem. We have a man walking here whose mass is m and this is 3m. And you know the result. X is equal to that ml by m plus m or whatever. Are you clear with this logic, everyone? Sure? That way. Now, if someone really wants to harass you, they will do something like this. We have 4 people, m, 2m, 3m, and 4m. So m will go to 2m ka position, 2m will go to 3m ka position, 3m will go to 4m ka position, 4m will go to m ka position. Then I can ask you find the displacement of the plank. Getting it? You can play around like this. So I will leave it to you. You want to try, you can try that. So you can play like that. Mass of the plank is m. So if all the 4 people are just walking in the anti-clockwise and they exchange places, then what is the displacement of the plank? Got the question? So I'll leave it there. You want, you can try. So, but you got the idea how to handle these things now. Clear with this? Now, the same thing, there are another variations, right? So I'll just show you the other variations. Last page, this one. Okay. Now, the same question, there are another variations. Okay, so these are important to remember. Mains mein they do ask. Question will be like this. So you have a balloon, mass m. And there is a rope here, and at the bottom there is a monkey. Something like this, small m. Okay, and balloon is in equilibrium. That means the gravity and the bind force is cancelling out. So let's not worry about that. And this is length L. So question will be like this. If the monkey starts climbing the balloon, find the distance traveled by the balloon. So if this monkey starts climbing the balloon, you will notice something of this sort. So initially, this was the balloon ka position. So as the monkey starts climbing, the balloon will come down a little. In this process, the picture will become like this. That means this is the displacement of the balloon. You're getting it? If the monkey climbs the balloon will come down a bit. And they'll ask you to find the displacement of the balloon. Now, think about the question. Doesn't this question kind of look like a plank of length L? Mass m is the balloon. Instead of monkey, there is a man, small m. So when the man walks here, the plank will come down a bit. The man has come to this corner here. Find the displacement of the plank. The result is ml by m plus n. Are you getting the thing? So they're one and the exactly same problem. You just change the terminology. Instead of plank, you say balloon. Instead of man, you say monkey. So the answer will remain same. Clear with this. So they'll ask this question, people will think this is something new. So you should know it is the same thing. All clear with this? One more variation in this. But any doubts, how did we compare this? Because see, Max doesn't care whether it is a balloon or a plank. As long as the mass is same, it will think it is the same thing. It is you and I who think this is a balloon, this is a plank. Max doesn't care. Same model, another variation. They will say we have a platform like this. This is mass m. Here we have a ball of mass small m. This is radius r. So when you drop the ball inside, the ball will start moving inside the, this wedge. And because of this, the wedge will start going backward, meaning the picture will become like this. Means when the ball reaches the lowest position, this wedge has moved a distance x. Then the question will be, how much did the wedge move when the ball has come down? Now, if you clearly look at this, so from here to here, this distance is also r. So this question is exactly like this. It's like a plank whose distance is r. Instead of the man, there is a ball. Because you understand one thing, we are only interested in the horizontal displacements here. The wedge will go only in the horizontal direction. So when the ball goes from one end to this end, so basically this was your center. Only the horizontal displacements will matter. So I think I'll show you the picture here only. Wait. So this thing has gone x backward. That means the ball has traveled r minus x. Agreed? So you're done. So x is equal to m into r by m plus m. So you can just replace that wedge with a horizontal platform and you can solve the problem. I hope everyone is clear with the variations. So I can say man is walking on the plank. I can say the ball is rolling in a circular arc. I can say the balloon monkey is climbing a balloon. All these questions, the story is the same. The different ways of asking. To make it a little tough, I can put two people walking on a plank. Put a square platform. This is even better. I hope all are clear with these models. This is one important model. Any doubts on this? Clear now, Utsa? Clear with this? Siddesh? Siddesh, clear with this? Shaunak? Advay? Shreyan? Great. Next thing, stability of systems. You must have noticed this. If you take an object, let's say like an L shape or something, and you keep it here, this won't remain at rest. If you take an object like this and leave it, you will notice the center of mass of this will be somewhere here. The normal reaction, right? Normal reaction is the force due to contact. So you're touching only somewhere here. So what will happen? This will actually topple. More about this we will study in rotation, but one thing is clear. This will not remain at rest. This will fall down. Since the normal reaction and mg are not along the same line, they form a torque. In school now, you must have studied the moment of force, which is torque basically, are not on same line. So the body starts rotating. That's what happens. If you try to stand on one leg and try to lean forward, you will lose balance. Because your center of mass is shifting forward, you can't handle this. But the same thing, if I take this L shape, but this time I put a big block also on top of it. Do you guys agree I can keep this at rest? If I can arrange properly, I can keep this at rest. The reason this center of mass and this center of mass, when you take these two, now the center of mass of the system will come somewhere here. So this gravity will actually pass through the line. So how can you keep a system in equilibrium? Yeah, it is the same thing, Shrihari. So there is the statement. As long as the mg vector from the center of mass passes through the boundary passes within the boundary of the area in contact. So whichever area is in contact, as long as you pass within that boundary, system will remain equilibrium. That means you can take a pen and keep it straight like this, as long as you can keep it, the center mass passes through the base. Uh, did you see anything like this before? When I was in school, we used to have a toy like this in the house. I was so excited I broke it one day. My mom took a stick and gave me right and left, but where is that? This one. Did you guys ever see this? We have a bird like this, and you keep the beak on that, and it is flying. Seen this anytime? Never seen this? You guys are missed out on a lot then.
Sir, I've seen.
Yeah, you must have seen this. I have this. I'll show you. So basically, this thing, right? It completely balances on the beak actually. Let me show you this after the break. Take a break. Come back by 9:40. We'll continue from here. We'll talk about this in more detail.
Sir, like
Any
there
doubts
is,
so far?
like sir, there was like one thing I'd seen. So like one restaurant actually has this challenge, like you have to balance it around the beak, and one guy actually did it.
अच्छा है ना then. Happens. Chalo, come back in 5 minutes. Oh, next, but yeah, anyway.
लेके तो नहीं गए वो लोग घर में तो मेरे को दिखती है
Chalo, camps on everyone. Let's start off. I couldn't find that bird. I think it's lost somewhere. But must have seen a toy like this. Let me see. Are those cams on? See. Okay, this was the thing I was saying. You can actually get this from Amazon. I think I bought it for last time 400 rupees or something. It just balances on your one finger, that beak. There. You can know it just balances on the beak. Can you see how it is floating on the beak? Never seen this? Also seen this thing somewhere in some other form. So I had this in the house. I don't know where it is. It's gone. I tried to find it. So this thing, I used to have this one when I was in school also. It was made of plastic. I was always confused, like, how the hell this is getting balanced on one thing. So one day I broke it eventually. And then I started seeing what is inside. I'll tell you what is there. But you can see that. See how it is floating. That is one. Then let's see one more.
People ask if it's glued,
Look at
if
this
it's
thing.
steel rods. A lot of people really don't understand that it's just
Can you see how the stones are balanced? So it gives you a feeling as if, just made them stuck with some external thing. But
balanced.
These mind-bending rock formations are held together with nothing but gravity. Rock balancing art predates the Bible and can be found at the balances around, and his creations have turned it into an internet phenomenon.
The structure that probably got me
so this
noticed
guy actually is a YouTuber. He became famous, for building the
kind of
structure
that
itself.
orb structure
I'll post
that
this
I
video in
made.
the group, you guys can watch it more.
And it's just hundreds of little rocks kind of balanced
Nice,
on a
no?
really tiny one at the bottom.
This is the most fun part, right? Build everything and break it.
Is to make the formation.
Look at his title, job ka title. Michael Grab, rock balance. See, that is also a job title. Yeah, if you are really good at something, right? He became famous with this YouTube thing and whatnot.
As impossible as possible at the time. Process while I'm building.
Yeah, so he
is
just
like,
builds with
I'm not
all
trying to
different
figure out
things.
that's
Like, he just
impossible,
sits there and
though.
aram builds it.
Especially when I try to take a huge rock and put it on a tip. And
Yeah. See, he just balanced it with his hands only, na? Kuch nahi hai.
then people are just kind of mind
So again, the idea is that only. As long as the centromast of the system passes through the base in contact, the system will remain in equilibrium.
blown when I actually let go.
Anyone can make rock piles, but Michael
So that's about Michael Grab. And this is another one.
Hello everyone, today's video I'm going to show you another cool experiment with gravity. All you need for this is a hammer, rubber bands, I'm using two of those, and it doesn't have to be rubber bands, you can literally just put the ruler to the rubber bands, like here, and I'm going to do it in the middle for now. And then I'm going to take the hammer and put it through the rubber bands, and I'm probably going to do it this way here, because it's just easier to hold this way. And I'm going to put it this way, like this. Check this out. The hammer is hanging. And I can actually put this on the edge, like right here. Now check this out. It's still hanging. Yeah, it hangs without no problems. Look at this. And obviously nothing under here and over here. Let's look at this closer.
You can actually even more to the edge. This guy is not doing it, I guess.
Hammer string onto the roof. Well, I hope we'll see in the next one. So what you want to do is put the rubber.
I think I have that also, I guess. I don't have that. Yeah. So what's exactly happening here? Why is that bird able to float? The thing was this: when I broke this thing when I was in school, what I realized was we'll see a problem on that rock thing. No, that thing you actually do it by experience. That guy doesn't measure or anything. He keeps one rock and then he's trying to balance one after another. That is the reason he is a rock balancer. So you and I can't do that, but that guy is a pro in doing that. I think comes with a lot of experience. Itna chod, the pen you have in your hand, we can't put that straight, isn't it? That guy is trying to put weird stones on top of each other. So when I broke this thing, what I saw was this. There was a metal piece here, there was a metal piece here, and there is a metal piece here. So there were 3 metal pieces. The rest of the thing was hollow. And these 3 metal pieces ka center of mass was falling somewhere here. And this center of mass is within this boundary, isn't it? That was the reason, no matter how much you disturb that bird, the bird, never falls down. So the trick, if you observe the picture again, can you notice this picture here? Can you see these 2 wings are so ahead? If I actually look this from the top view, such kind of birds don't exist. The bird is actually like this, isn't it? The wings are completely front. So it gives you an illusion it is a bird, whereas in reality, if you look at this part, can you see how much it is stretched from the bird? They actually form an equilateral triangle, and the centroid, the beak will be at the centroid. And they do it very smartly. Look at this thing. They made the base very big. So even if the center mass gets tilted a little bit left and right, it is still within the region, so it's still stable. Are you clear with this? So this thing you actually get it in Amazon. You can just search it as as a balancing toy or something. Last time I brought it for 350 rupees or something. It's an interesting one. When you show it to people, they always get surprised, like, oh, it actually floats. So let's see a question based on this. Let's say you have planks. We have a plank. We have a plank. One more plank. One more plank. And let's say you kept this thing on a table. Getting it? So we have 4 identical planks of length L. I'm sure you must have done this in school now with your notebooks. Do you ever try like this thing? Keep one book on top of another and try to extend it outwards. I think it is all. We used to do all this kind of nonsense in school because we never had phones and all, no? So we had to keep ourselves entertained. So this is kind of the nonsense things we used to do. You guys play PUBG and CS:GO and everything. In school, we used to fight with each other and beat each other. That was a PUBG for us. So that is the only difference. It is not like, you guys are sincere and we guys are, we are sincere and you guys are not sincere. Every generation is hopeless only. The only thing is your generation has more ways to get distracted. Bus. So in that way, if you see, actually we are more evil people. You guys are actually more, gentle creatures actually. During Diwali, what we used to do? We used to have rocket fights. During Diwali time, there is a street, na? People on the other side of the street are throwing rockets at our places and we are throwing rockets on their houses. I was seeing Diwali this time, I was thinking that only. What kind of weird things we used to do. So we got 4 planks here. Each plank ka length is L. Okay? Now you can arrange them however you want. So this plank, let's call this point A. So arrange however you want, but make sure this distance is maximum so that the planks don't fall down. I don't want the planks to fall down. What is the maximum value of X? Such that planks remain at rest. So you have 4 planks of length L. You can arrange however you want, but I don't want any of them to fall. Matlab, I don't want this to happen. Huh? This should not happen. If you don't put properly, the planks will fall off like this, isn't it? We don't want that thing to happen. So what is the maximum distance of point A? Means what is the maximum distance you can push the planks outside without losing that stability? I hope the question was clear. Anyone didn't get the picture, please ask me. You have 4 class note ka books. You kept one book, you kept another book on top of it, another book, and you're just pushing them slowly out of the table. What is the maximum you can extend it outside from the table horizontally? How do you handle this? Remember the concept. For a system to be in equilibrium, the center mass of the system should pass through the base on which it is lying. Think for a minute, I'll show you. This is a little different one. Nere Arya. Nere Samya. How did you get such a weird number, Arya? 77. That is an interesting number. So let me help you. Let's start from the top. Don't go from the bottom. So let's say from the top plank. Where is the center of mass of the top plank? At the center. Now you tell me, for this to be in equilibrium, there should be some surface below the center of mass, isn't it? So where can you keep the second plank? The second plank will lie exactly below this, isn't it? Everyone agrees with this logic? To keep the top plank at rest, uska center of mass should pass to the second plank ka base. Since you want to keep it at maximum, I will put it at the extreme. Meaning this will be your C2. What will be this distance here? Then this will be L by 2 because half of the plank. That means you can put one plank at a distance of L by 2. Now look at this thing. So C1 and C2, these two ka center of mass will be somewhere here, which is C12. Now you tell me, to keep these two planks at rest, where should I keep the third plank? The center of mass of plank 1 and 2 should pass exactly below the third plank ka edge. Are you getting the argument how we are doing this? Whatever is there on the top, uska center of mass should pass through the base, isn't it? So for plank 1 and 2, the center of mass should pass through the edge of the third plank. Are you clear with that argument? Are you sure with this? How much will that distance be? Now look at here carefully. This is C3. So this is C1, 2. This is C3. And you can clearly see this distance will be how much? C1, 2. No? So this is the edge, right? So this distance will be L by 2. I'll just draw that again. See. This is C3. So exactly on top of it, you have C12. This distance is L by 2. Okay. So just for exaggeration, so C12 and C3, this mass is 2m and this mass is m. And the distance between them is L by 2. Where will the center of mass be? The center of mass will be somewhere here, closer to this center of mass. And we know the center of mass will divide in the ratio of 2:1. So it will divide in the ratio of 2:1. So this will be 1/3 of L by 2. So this distance will be L by 6. Meaning this distance will be L by 6. No, wait, why am I doing this? This thing I know clearly actually. This is L by 4 actually. You don't need to do that. That is L by 4. I'm doing it for the next one. Now the center of mass of 1 and 2 and 3, that will be somewhere here. This will be C1, 2, 3. This is the center of mass of 1, 2, 3. That we calculated right now. How much we got? L by 6. So this distance will be L by 6. That means you should keep the fourth plank exactly below this guy. Are you getting what I did? Where will the next center of mass be? C1, 2, 3 and C4. This mass is 3m and this mass is m and this distance is again L by 2. This time when you calculate the center of mass of this guy, you will get the center of mass will be, this in the ratio of 3:1. This will be L by 8. Next one will be L by 8. Actually, you'll observe a sequence by now. So the next plank should be at L by 8. Suppose if I had kept one more plank, I didn't ask you, but the next plank will be at L by 10. Next plank will be L by 12 and so on. Are you clear with this thing? So they'll actually form a sequence like this, but anyway, our question will end at L by 8. 4 planks, no? So L by 8, this is your table. So your distance x will be L by 2 plus L by 4 plus L by 6 plus L by 8. You can remember the sequence. Are you clear how we did this? So center of mass of the first plank should pass through the edge of the second plank. the center of mass of the first and the second plank should pass through the edge of the third plank. Center of mass of 1, 2, 3 should pass through the edge of the fourth plank. And center of mass of 1, 2, 3, 4 should pass through the edge of the table. Are you clear with this? And this will form an harmonic progression. कितना आएगा ये? 3 by 4, L by 8, 6 by 7 by 8 plus 50 by 48, 25 L by 24. Check your answer. Right, Utsa. Remember this result is useful. Exam, you won't have time to derive the whole thing. But I hope you're getting the idea there. So here the idea is this. Center of mass of plank 1 passes through edge of plank 2. Center of mass of plank 1 and 2 passes through edge of plank 3. And so on. Are you clear with this? With the planks, we can still play around. So this thing is still, you can calculate. Now, like over here, you're asking, now, what happens if it's an irregular shape? It's very difficult. You can't do this with any calculations. वो तो experience ही आएगा, how to make them stand. Any doubts on this? All clear with this thing? It's a good question. If you know the result, it becomes pretty easy to solve. Clear na, Arya? Trishi, clear with this? Arya, are you there? Clear na, Arya? Let's see few more questions. Now let's go more into momentum. These problems will be good today class, and this problems in the next class. So we have a plank wedge. This mass is 2m. Here we have a ball, mass is m. This is a circular track, quarter circle of radius r. This is a wedge with a circular track of radius r. All surfaces are smooth. Wedge is smooth, wedge ka floor is smooth. Let this corner point be A. Find the speed and the normal reaction of the ball when it reaches point A. So you gently pushed it and the ball starts rolling. The mass of the wedge is 2m, ball ka mass is m. Find the speed and the normal reaction when the ball reaches point A. There, now we have completely gone into momentum. Think for a minute or two, then I'll show you. root gr by 3. Normal reaction, na? Speed of the ball I need. Okay, that is fine. You got the speed right. Right, Siddesh. I know, I think. No, Siddesh, I think you got speed of something else. You didn't get the speed of the ball. I think you found speed of the wedge. Now listen, this is important. Yeah. Wedge is also moving, na? Did you forget that? No, Samyak, that will be wrong. Listen, listen, everyone. This is important. Huh? More than the problem. When you see a problem, now see, you must have noticed something. Now things are actually increasing. When we started, and initially we had FBDs and everything. Then we had conservation of energy. Now we are having conservation of momentum. Now, as you observe, right, things are piling up. Things are becoming more and more complex. So when you see a question, how do you get an idea, boss? I should do this and not do that. So this is again, not a physics concept, but when you do a lot of problems, you'll understand this. This is how I think. So listen carefully. When you give me a question in mechanics, you have only two set of weapons. One set of weapons is your force and torque equations. Torque we still didn't do, that comes in rotation, but idea is the same. You have only two weapons, force and torque equations. The second set of weapons is conservations. It's like, if I have to write a program for a computer to solve problems, this is how I'll write an algorithm. Right? You make a flow chart or something. Now, how do you know which method should I use? The thing is there in your question only. You will see words like this. You will hear words like find tension, find normal reaction. Tension, where did you see? It comes in an FBD. Normal reaction comes in an FBD. Acceleration comes in F is equal to ma. So you're basically talking about the loss of motion. So when they use words, find tension, normal reaction, find time, means kinematics, and kinematics ke liye you need acceleration. So when you hear words like this, 95% of the time, it is mostly force and torque equations. Maximum number of times. Exceptions are there, but in general. How do you know you have to use conservations? You will hear these kind of words. Find speed at that position, find the maximum height, find the elongation, max compression, right? Meaning, if you see these words now, you will notice a kind of a theme. You don't care what is happening in the middle. You're always interested about final position. The whole question when you read now, it gives you a feeling, boss, this is always about the final. Look at the previous question. Find the speed and the normal reaction when it reaches A. Matlab, I don't care what is happening in the middle. Find the speed there, find the velocity there, find the height max, find the maximum elongation. It is always about final position. So that is like a clue. Okay, maybe it is about conservation, because think about it. Only in conservation you define state 1 and state 2, isn't it? So when I say find the final speed there, indirectly you're telling that is a state 2. Then what? So once you decide which method to use, if I have to use force and torque equation, step 1, we draw FBD. Right? Then we calculate the forces, resolve forces. बाद में देखेंगे. We'll calculate torques also. Then we use constraint equations. It becomes your regular kind of NLM. Once you got all those equations, then we apply either F is equal to ma, or for torque, we apply something called torque is equal to I alpha. And then we solve. But if you decide it's your conservation, then we draw the final picture. You have to draw the final state. Now in mechanics, we have three conservations. Then we have, you can either conserve energy. This we did in the last chapter. We can conserve linear momentum. Currently, we are doing it. then we can also conserve angular momentum. This we will see in rotational mechanics. So there's a third conservation which will come in the next chapter. Conservation of angular momentum. That means you can use three conservations. Now you cannot use the conservation directly. You need to satisfy some condition. When can you use work? You can use work if work done by external force is zero. When can you use momentum? Use this if F external is zero. When can you conserve angular momentum? Use this if torque external is zero. And then once you get whatever information you have, you solve. Are you getting this? So this is how my brain thinks when I see a question. Now, if you see this question, find the speed. Matlab, you're talking about conservation, normal reaction. You're talking about an FBD. Are you getting it? You have to use both of them. But in order to find speed, you're asking find the speed at A, matlab final state. Understood, I have to use conservation. Are you getting this? This is not a perfect thing, but when you solve a question, this is how you should think. Clear with this? So what happens in the exam, right? If you start thinking like this, in the exam, when you see a question, your brain will figure out how to handle it faster. Most of us have this problem now. You see a question and keep staring at the question. Abhi kya karna hai? Abhi kya karna hai? We don't get the starting point. So let's solve this question. So we are trying to find the speed. Meaning you're asking find the speed at the final point. It is clear, conservations. So draw your picture. So initially ball is here. This is state 1, 2m and m. Final state. The ball must have come here. The ball is going with speed v1. The wedge is going with v2. Why are they not going with the same speed? Because the masses are not equal. See, I don't know. Don't guess that the speeds are same. We don't know. So let the speeds be different. Let it be v1 and v1, v2. Because since the masses are different, I'm getting a feeling velocities will be different. If you think they are equal, prove it. So this ball from here to here has fallen a height r. This is my state 2. Perfect. First thing, if you look at the system, horizontal forces are 0. Remember, vertical forces are not 0. There is a normal reaction on the ground. Horizontal forces are 0. Therefore, horizontal momentum is conserved. If the forces in a particular direction is 0 and the momentum in that direction is conserved. So initial momentum is equal to final momentum. What is initial momentum? 0. Everyone is at rest. What is the final momentum? mv1 right side and 2mv2. There, as expected, the speeds are not same. v1 is equal to tv2. Means if the ball goes with speed, wedge goes with v2, the ball will go to double the speed. Is that making sense? If you think about it logically, since there are no horizontal forces, center of mass will not move in the horizontal direction. So momentum is done. And work done by external is also 0. Other than gravity, normal force is internal, there is no work done. Therefore, I can conserve energy also. So there we can use two conservations at the same time. Loss in gravitational potential energy is equal to gain in kinetic energy. I hope you're getting it, how we are doing it systematically, step by step. This is how you think when you're solving a problem. Blindly, if you solve and you get an answer, but you don't know what you did, that will not help you. You will not improve. Then this will be half m v1 square plus half 2m v2 square. You're done. Take that v1 or v2, substitute here. M gets cancelled. This will be 2gr. This will be v1 square. This will be 2 v2 square is v1 square by 4. That will be half to 2 root gr by 3 or root 4 gr by 3. Clear with this? This is the speed of the ball. You found the speed of the ball. You're done. Any doubts on this? Please have a look at this page. All clear with this? Great. Next thing, what did I ask you? Find the normal reaction. Means you have to draw the free body diagram. So the ball is here. Draw the free body diagram because you can get normal from there only. What are the forces? Normal reaction, your own weight mg. And this guy is going in a circle. So there will be a centripetal acceleration v square by r. But be careful, what is v? Actually, v is the v relative. You guys remember this? I taught you this in circular motion. Here is this. There. ये question याद है? Note. A centripetal is v square by r. V is the velocity relative to the platform. Page 53. So a centripetal will be v square, v relative square by r. So in this scenario, you can clearly see the ball is going with v1 and the wedge is going with v2. So this will be v1 plus v2 whole square by r. That is one of the common mistake people do. So you have to be careful there. You are done. So then it is n minus mg is equal to mass into a centripetal. This is m. What is v1 plus v2? This is 2 root gr by 3, and that is 3 root gr by 3 ka whole square by r. That would be 3. I'm getting 4 mg. That's your answer. See where it went wrong. See how many concepts we had. Conservation of linear momentum, conservation of energy, loss of motion, circular motion. 4 chapters. And this is not even the final form of the question. The same question we'll do again in rotation. So this thing is like, you know, what do we call? Oh, Pokemon mein hota hai na, Pikachu and Pikachu ka next level. This is the first level Pikachu. So this will even transform into a bigger problem in rotational mechanics. But any doubts on this, please ask me. Clear with this, Vedika? Vedika, clear with this? You guys have any issues, you know, you guys need to switch off the cam, need to go to the washroom, that is fine. Just leave a message and go. If you keep your cams off for long, then I'll think you're sleeping. Teachers have to be suspicious. That too, physics people are very suspicious. Clear with this? So what happened? Like holidays, 1 week ka break aa gaya, so people are still in that holiday mode. Kya? People still didn't come out of the holiday vacation ka stuff. It will take, I understand, there is that, you know, inertia. It will take 4 or 5 days a week to get used to that. But I hope at least you guys chilled out a bit in the vacation, because after, I don't think you'll get any good holidays after this. This was your last vacation technically. Let's see one more. Let's do something more easy. Let's say we have a platform like this. This mass is 2m. Here we have a block of mass m. This is given speed u. All surfaces are smooth. So from here to here, this height is h. So A is the topmost point on the wedge. Then it starts becoming straight. The first question, find u minimum so that block reaches point A. Just to give a little context, try to understand when the block is coming here, what will happen? Because of the normal reaction, even the wedge will start moving. Na? The wedge will not remain at rest because the ground is also smooth, wedge also will start moving. So this is not like your previous problem where the wedge was fixed. Second thing, suppose instead of this, if you give u is 2 times u minimum. So if you give 2 times the minimum speed, find Hmax of the block. And describe the motion of the block after it loses contact. Let's get this. It's a good one. Let's do the first part. I'll give 2 minutes for that. If you're giving more than minimum speed, it will just fly off into the air. So what is a Hmax? And then can you describe how the block ka motion will be? Hope the question was clear. Anyone not clear with the picture, please ask me. Right, Siddesh. Right, Arya. Got the first part. Go ahead with the second thing. Try others. You have to reach point A. So state 1, state 2. We have to use conservations. As this thing is going up, it will push the wedge also. So both will have some speed. Conservation of linear momentum, conservation of energy. Think. Try. I'll give you a minute or more. Just give it a try. Get some water and come. Let's see. Right, Samir. नहीं हो गया. Oh yeah, think about this thing. Huh? Suppose if the wedge is also not moving, then the minimum speed is root 2gh, isn't it? And if the wedge is moving, you need more than that. Trishi, question is clear, no? Trishi, question is clear? Yeah. नहीं रे सिद्धेश. Chalo, let's see the first part, okay? Listen carefully. Always define your initial and the final state. Again, make sure to solve all the problems we did today again. That is how you learn better. So this was the scenario. Your block is here, mass is m, your speed was u, the 2m was at rest. Okay. Now, as this block starts climbing up, because you're pushing the wedge, even the wedge will start moving. So when the block reaches the highest position here, this block will have two velocities, technically, Vy and Vx. Since the block and the wedge are touching each other, they should have same horizontal velocity. Do you guys remember? Velocity along the normal must be same. Since they are in contact, they must have same velocity along the normal. So this is the normal. This comes from rigid body constraint. If two bodies touch each other, then the velocity along the normal must be same. They must have same velocity along the normal. And this height is h. There, I'm just putting a picture. I didn't start even solving the question. This is important. You need to get the picture right first of all properly. So this is my state 2 and this was my state 1. Since horizontal forces are 0, I can conserve momentum. Because horizontally there are no forces, friction is 0. Therefore, momentum in the horizontal direction P initial is equal to P final. So what is the initial momentum? M into U. Only the block is going, wedge is at rest. What is the final horizontal momentum? Horizontal momentum, M into Vx plus 2m into Vx. That means they're going horizontally with a speed of U by 3. Next thing. What about this Vy? Vy will be 0 because you said the minimum speed. Since the speed is, we need minimum speed, the block will just reach A. Since block just reaches A, Vy must be 0. In the second case, Vy won't be 0. Since work done by external force is 0, conservation of energy. Initial energy is equal to final energy. Initial energy half mu square. Final energy will be half mvx square plus mgh. This is for the block of potential energy and the kinetic energy. Plus wedge will be half 2mvx square. There, you got the values there. So this thing is the block of potential energy plus kinetic energy. This is your wedge. You know all the values there. You can substitute. So Vx will be U by 3. That will be 3 by 2. So half mu square minus 3 by 2m Vx square is equal to mgh. Solve this, you'll end up with, we get U minimum will be root over 3gh. Check. Arya, bolo na.
Sir, I think it's also important that we acknowledge that if that block wasn't at that topmost point, let's say the ramp was still some angle theta, both the velocities wouldn't be same along the normal. I mean, not along the normal, along the x direction.
Then we won't call it x. Na? X along the normal they should be same. Na? X ka same hone ka zarurat nahi hai. Yeah.
But yeah, we couldn't conserve the momentum then. I mean, we would have many unknowns and less equations.
ऐसा बोल रहे हो ना? If you're saying you want like this. So if the question is find U minimum, na, U minimum meaning at this point the relative velocity became 0. They started going together.
Yes.
Means with respect to the wedge, it has come to rest relatively, momentarily at rest. So they'll have same horizontal velocity. No? If you say find the minimum speed to reach point A, means when it reached point A, it stopped going higher, isn't it? Means with respect to the wedge, it came to rest momentarily. So even then we can argue like, they'll go with the same horizontal velocity. So usme issue nahi aayega.
Okay, sir.
All clear with the first part, everyone? Now the second part of the question, instead of this, if I give 2 times the speed, matlab if you give 2 times root 3gh, then what will be the maximum height and can you describe the motion? How will this block move? 4h, right Samyak? Right Siddesh? Think, others, I'll give you a minute or two. It's completely fine if you don't get how to do, but if there are 5 steps, at least try to figure out 1 or 2 steps. It's important. I'm giving you time to think. So it is think about this. Don't worry about like you didn't get or what. Right, Arya. Let's see the second part again. Let's draw the pictures. If you see, I draw a lot of pictures. This was the initial M. Now you are giving U is 2 times root 3GH. Right. Then what will happen? This block will reach this position here, M. Now this will have velocity Vy. Now Vy won't be 0, and this will be Vx. The wedge also go with Vx because we proved it just now that they should have same horizontal velocity. And this height was h. State 1, state 2. Conservation of linear momentum. Mu is equal to mvx plus 2mvx. Only horizontal force is 0. Vertical force is not 0 because there is a normal reaction. So Vx is u by 3. Then conservation of energy. Half m u square will be mgh plus half m. The block will have two velocities now, Vx square plus Vy square plus half 2m Vx square, the wedge ka velocity. So this whole term is block ka energy, potential plus kinetic. This is your wedge. Substitute the values. U will be 2 root 3GH, that will be 4, 3, 12. This is mgh, that will be 3 by 2 mvx square plus half mvy square. This will be 6. If you bring this thing, this will be 5 mgh. This will be 3 by 2 m u square by 9. Then we will get u is nothing but again 2 into root 3gh. That will be mu square by 6, and u square will be 4, 12, 2gh, 3gh. So you get Vy square will be 6gh there. So at that point, the vertical velocity is root 6gh. Clear till here? Now something interesting happens here. See, that means this block will have vertical velocity and horizontal velocity. Now tell me one thing. If a block has horizontal and vertical, how do you think it will fly? Right, Ovia? Utsa, I think you got it. You forgot to add h. The block will start flying like a projectile motion, na? The block will start flying like a projectile. So let me show that in the next page. And something interesting happens here. When the block flies in a projectile, tell me one thing. What is the wedge doing at the same time? At any instant, if you see, this block will have a velocity Vx. At the same time, the wedge will also have same velocity Vx. So this block will come and exactly land on the wedge again. So this block will come and again land on the wedge. So here the block moves in a projectile. And since the block and the wedge have the same horizontal velocity, that means, you know, the block is always exactly under the wedge. So if you try to draw the picture, the block will be always like this. The wedge is exactly following below the block. Block and wedge have same horizontal velocity. Therefore, the block will again come and land on the wedge. So they can ask this question: for how long will the block lose contact with the wedge? Time of flight. You're done. So basically this has become like a projectile motion, and this will be your Hmax. How much is this Hmax? Vy square by 2g. How much is Vy? 6gh. So this will be 3h. But you're asking from the ground level, no? So total height will be h plus 3h. Clear with that, Utsa? I think you forgot to add that h there. So the total height will be h from the ground level, and then you'll go in a projectile motion, you'll go 3h, so total 4h. Is that clear, everyone? Are you getting why it will fly like a projectile? Because when it is losing contact, it has horizontal velocity, it has a vertical velocity. Why will it go straight up? In the ground frame, you will think it is flying in a projectile. It goes and lands again on the wedge. That's what makes this question really good. Any doubts on this? So after landing on the wedge, again it will slide and again it will come out. So you can still play around more, but I think you got the idea. Clear, Aditi? Devanshi? Clear with this? Pratyasha? There, have a look at this. It's a pretty good one. So make sure to go through all the questions we did today. Some of them are really good. We have different variations there. You should definitely try them on your own again once more. Next class, when we catch up, we are going to do more things of this. We will get even much better problems than this. So next class will be important. So when we catch up on Thursday, we'll continue from here. We will see more variations of this. And do remember, this week there's a test online till Friday. So make sure to give it. So any doubts, anything else, please stay back or else you're free to leave. I'll see you on Thursday, same time. So take care, stay safe.